giving you some more grades. So let me put this up here and make it all official. I decided to shorten quiz Thursday down to just doing 5-6. Tomorrow will be 5-5. Thursday's 5-6. So this is graphing polynomials using multiplicities and finding zeros of polynomial, all that kind of stuff. And then this one is rational functions, asymptotes, and all that kind of business. So we're gonna finish that up today. Before I forget, can everybody right now, has everybody got their phones? Normally I don't want them out, but take them out. If you haven't done this already, if you could just really quickly, did anybody finish the survey? Hold on, you gotta put it back to the survey. How long was it?
It was like a minute, less than a minute, yeah.
Like, okay, good. They told me it wasn't too bad. I'd have to go through it myself to see it. I didn't tell me. So if you guys could snap that and fill that out for me, great. If you really don't want to, you don't have to. I can't force you. But do it. No. Even if you've never been in Math Science Center, one of the questions is, have you been to the Math Science Center? If you say no, they'll follow up with other questions. Right, okay. Everybody got that? Okay. Any other questions from homework stuff? Okay. So let's get back. I think, does anyone else need this sheet here? Okay.
Can you just erase
Sorry?
the equation on the whiteboard?
Oh yeah, sorry. Oh yeah, it's here. All right, do it again. Sorry. Who needs it? Yes. Also, let me see, just while I'm thinking about it, let me give back some stuff here. Jonathan, Timothy, Andrew, Eduardo. Seven's not here. Mosauer's not here. Giovanni, David, Lambren. Oh, which one are you? David. All right. Mariah, Saulo. Rami Yakub. Rami, okay. All right. Someday I'll see them again. All right, so everybody's got this sheet. I gave this out at the end of the last class, and we haven't even looked at these problems yet. So I summarized, and I try to make it a little better by color coding it a little bit, so your eyes can kind of gravitate to the important parts easier. Anytime I try to capture a general idea, it's going to look a little bit worse. But n is just the degree of the top, m is just the degree of the bottom, yes? So if the degree of the top is smaller than the degree of the bottom grows faster, the whole thing goes to 0. That's what we did yesterday. Yes? If they're the same degree, neither one grows faster than the other one. They're going to kind of agree on a middle ground. And it's going to be the ratio of the leading coefficients. So if n equals m, if the degrees are the same, you just have to divide the leading coefficients and you get what the horizontal asymptote is. And then this one we haven't talked about yet. We will. I'm going to do a few examples with 1 and 2, and then we'll talk about 3. 3 is its own beast. We'll take a look at it. Okay. So if you weren't here yesterday, oh dear God, watch that video if you want to. If you don't want to understand, you don't. For the very first thing, does somebody remember the very first thing you should do when I give you this kind of problem? What kind of makes sense? Yeah, factor away. So go ahead and factor the top and the bottom of that rational function. All right, let me see. I'm going to catch up. Okay, so first question I have is right there. What are the intercepts? Now be really careful. When I say find the intercepts, I mean both x and y. Find the intercepts means all of them. Say again? Almost. 0, 1, but I'm being a little bored, but that's my job. Yeah, so can somebody tell me why she found the y-intercept so quickly? How do you find the y-intercept always? You make x 0. And if I make x 0, I get negative 3 over negative 2, 1/2. So the y-intercept is 0, 1/2. What about the x-intercepts? Why can I see them easier now? What's the only way a fraction can be 0?
The numerator is 0.
If the top is 0, right? Because if the bottom is 0, it would become. What do I get if the bottom is 0?
Undefined.
Undefined or infinite now, we know better because it's like an asymptote there, yeah. So when I ask you for the intercepts, I always get somebody's going to tell me 4 x-intercepts here. They're going to say it's negative 1, 1, negative 3, 2. But negative 3 and 2 are the opposite of x-intercepts. X-intercepts are where the function exists on the x-axis. The bottom makes it undefined. Those would be where it cannot even go at all. How are we doing so far? So there's only 2 x-intercepts here. You could even go one step further. Can somebody tell me what this graph is going to do at those x-intercepts? Yeah, is it going to bounce or go through? Why is it going to go through? Both.
Got a multiplicity of
They
1.
both have a multiplicity of 1. So it's awesome. The old ideas we're using still apply. When you get the x-intercepts, you can actually see if they're going to bounce or go through. We know they're going to go through both. Let me stop for a minute. There is something I'm thinking I want to show you. Yeah, let me. Yeah, okay. We can do it on this one, yeah. Okay. Now, can somebody I haven't heard from yet tell me, does anyone know what the vertical asymptotes are? Where would they come from? Yes. But I've heard from you. So x equals negative 3 and x equals 2, because that makes this thing undefined. In fact, it makes it more specifically, it makes it grow without bound. So it's going to go up forever or down forever, depending on if it makes it positive or negative. You stop for a minute. So this is everything we talked about yesterday, about these asymptotes. Okay. Now, what would I have changed if I wanted it to be not an asymptote but an open circle? What would have had to have shown up? If I wanted an open circle at one of these x values instead of a vertical asymptote, what would have had to have happened? Say I want an open circle at x equals 2. What would have had to happen? Do it again. Not x plus 2. Right? The fact that this is here makes there be a vertical asymptote at x equals 2. How would I make this go away? How would I make this go away? If the top had x minus 2 instead of x minus, then these would have canceled, yes? I still couldn't use 2, because that would officially make the bottom 0. I can't use 2, but it wouldn't make it go to infinity, because the top and bottom would be shrinking at the same rate. I really want this to make sense. We saw this yesterday with the tables we made. Okay. What situation are we in for the horizontal asymptotes? Yeah, what's the degree at the top? Second degree. And what's the degree at the bottom? Second degree. So I'm in this situation here. The degrees are the same. So the asymptote, the horizontal asymptote is going to just be a ratio of the leading coefficients. What's the leading coefficient on the front, on the top? 3. What's that on the bottom? Is the leading coefficient on top? I'm sorry, on the bottom 1 because the first term has a 1. Is that why? No, it's because the highest degree term has a 1. So you got to be careful. If it's out of order, the leading coefficient might not be in front. We call it leading because if I put it in descending order of power, it would be the coefficient that's in the front. So in this case, we got lucky. I put them in order for you. You've met me before. You know I might switch something. Right? Because I am evil. I told you that. Okay.
Wait,
Yes?
everything makes sense, but how did you, for the x-intercepts, how did you get -1 and 1 again?
Oh, how do you make a fraction 0?
Oh, by taking, okay.
Yeah, so then I'll look at the top for the x-intercepts, I'll look at the bottom for the vertical asymptotes.
Got it.
Okay, I like it. And by the way, I say this all the time, this is not intuitive. You're not born, they don't smack you in the ass and you go, vertical asymptote, no. Right? I mean, this is non-intuitive, so I need you, when I explain this stuff, I have to be careful, because I'm trying to show you it's not as bad as it first seems. But sometimes I use a tone that makes it sound like you should know this already. That's crazy. This is weird shit. It's not immediately obvious. Okay. So part C, the horizontal asymptote is going to be what exactly? Y equals 3. Good, because asymptotes are lines. So don't give me a number answer. It's got to be a line answer. X equals -3 is a vertical line. Y equals 3 is a horizontal line. Yes, sir.
How'd you get the horizontal asymptote?
So are the degrees on the top and the bottom the same?
Yeah.
Yes.
Yes. So therefore, it's going to be a ratio of the leading coefficients. 3 over 1.
Gotcha.
Cool. And real quick, you can see that now that I've shown you. Remember when we divided by x squared and blah blah blah? We don't have to do that shit ever again. When x gets really big, if you took $3 away from me right now, I need that. If I suddenly won the lottery and made like $50 million and you took $3, would I be as worried? No. So as x gets really big, how important is -3? Does it really do shit to me? No. 10 minus 3 is 7. That changed quite a bit. A billion minus 3 is still basically a billion. Yes? You guys with me? All right. So that goes away when x gets really big. When x gets really big, -6 is not shit. Yes? When x gets really big, X means nothing compared to x squared. A billion is big. What's a billion squared? Do you even know the word for it? Holy shit. So a billion squared is stupid big. So I would never prove this way, but now that you've seen the official proof where we divide by the highest power, I could just sort of do this. All these things don't mean shit when x gets big. And what does that reduce to? What's left? What's left? What does it reduce to? 3. There you go. So when x gets really big, the outputs are effectively 3. Okay, and watch this. Okay. Watch this. I didn't bring my calculators, but if you have one, you can do this with me. Let me show you a couple things, really. I think I showed you the store button before. Yes? So watch this. This is neat. I'm going to put 100, and I'm going to store it in X. And the great thing about doing that is, if I were to plug 100 into this, I can literally just write it exactly as it is. Now I know I have to put parentheses, so I can say 3x squared minus 3. Check. What happened? Divided by x squared plus x minus 6. 100, that's not nothing. That's decently big, but let's see what we get. All right, is that close to 3 already? Yes. What if I just put a 10 in? If I store 10 in X, and then the real neat trick is if I hit second enter, it goes back to this, and I can tell it to reevaluate that, but now it knows X is 10. Am I as close to 3 as I was a minute ago? No. So as X grows, at 10 it's here, at 100 it's here. So does it look like it's getting closer to 3? And of course, if I put 10,000 into X, and then I hit second enter, and told it to redo that, but now X is 10,000, now it's like basically freaking 3, yes? So as X gets big, all the other pieces that aren't squared mean nothing. Why isn't this perfectly 3? Because they don't mean exactly 0. They still mean something. They still do something, but they do so little. In fact, let me see what this, I think if I just do this, 99999999999, it might freak out. Ah, there you go. At some point, the calculator just gives up and says, man, that's like 2.309. I'm just going to call it 3 because my screen isn't big enough for all those 9s. You see what I'm saying? At some point, the calculator's just like, it's freaking 3, man. So even a calculator's like, dude, let me stop for a minute. So I really hope it makes sense why the horizontal asymptote is what are the outputs doing when X gets big. And when I put really large values in for X, these things don't mean anything. So it's essentially 3. If it's not really big, like 10,000 is not really big. It isn't. It's not exactly 3. And to be really honest, it still is not exactly 3 here. It's just so close to 3, the calculator's like, it's freaking 3. Okay. Maybe. Why exactly did we do 3 over 1 here? What is it that told us that would be the answer? Why did we say 3 over 1 was the y, was the horizontal asymptote? What situation were we in?
That they were the same degree.
Same degree. If the bottom degree is higher,
It's
the bottom scoring faster goes to 0. The x-axis would be the horizontal asymptote. Okay. And then if the top's higher, we have to talk about that. I'm going to talk about that separate because it's a freaking little dude. Okay. It involves long division, so just to give you something to look forward to. How bad is the one in the back? Not too bad. Okay, you guys can do that. All right. I'm gonna do this again. Do you guys remember when I did this with graphic polynomials? I'm gonna give you some values to help you figure things out. But what I wanna do right now, let me see. I can't really do it on here. Let me do it up here. Because I miss writing on the board. Here, you come here for the moment. Look, it's everybody. Okay. This is such a cool idea, and I need you to see this idea by itself. What we're about to do, let me see if you guys agree with me. I'm not going to put scale up here, so I'm going to be very undetailed because I just want to talk about a broader idea. What are we about to do? What would I do for this fact? What would I put on my graph to designate those? The vertical dotted lines, right? So I'm going to put like here and here. Is that cool? No scale, just talking about an idea. What would I do for y equals 3? Horizontal dotted line. Pop, 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 pop. Now, here's the idea. And I don't know why I don't stop and just talk about this idea by itself, because this is huge. We're about to graph a function. You guys with me? What does it mean that it's a function? What can it not do since it's a function? What does it have to pass?
Vertical line test.
It's got to pass vertical line test. So there's no way it could be here and here, yes? Okay, so I need you to, what I just did is huge. I just drew something out in my hand because I can't help but do it correctly because I've done it so many damn times. Do you see how this is 3 regions? There's 3 regions, yes? So look here. What does it have to do with all of these asymptotes on the outside? Doesn't it have to approach this? And doesn't it have to run up against that one, yes? So do you see how it could either be here or here? Not both. So it's one or the other, yes? So if I have an x-intercept here, it's not that one. If I have a point here, it's not that one. Do you see what I'm saying? So what could go on in here sucks. Let's talk about this one first. Again, this is basically the same idea, right? It's got to slam up against that, it's got to slam up against that. Or if there's an x-intercept, it's got to slam up against that, slam up against that. Do you guys see when you put those dotted lines in, you are literally putting walls on your graph, and it's limiting how much shit it could do. It's making it easier to graph. You just have to know a few points, which is why I told you -4 and 3, and we'll see why. In the middle, this is where things get weird. If there's an x-intercept, if there was no x-intercept, let me say this. If there was no x-intercept in the middle, can anyone see what it would have to look like? Just focus on the middle. Doesn't it have to run up against this wall? Is everybody with me? Doesn't it have to run up against this? So like it has to do this, or it has to do that, yes? But if there's no x-intercepts, it has to look like a parabola, either down there or up there, yes? If there is an x-intercept, then it could look like a cubic almost, yes? Do you guys see that? There are limited things it could do because we have put walls in. Yes?
Why is it able to do that if there's a vertical aspect?
That's not vertical.
I mean,
Is everybody cool with this? Look, several times I went through, didn't I? Why is that okay? When does that come into effect? When x gets really big. It's like an end behavior thing. Is x really big here? Because here's 0. Is x really big yet? No. So it could, and I've shown you situations where it can go across a horizontal asymptote an infinite number of times, yes? So this is you cannot go here. This literally is you cannot go here, yes? This is, hey man, if you got a second, can you get close to me? Right? So in the middle, I can go through it as many times as I want to. I just have to eventually start getting close to it. This one is, holy shit, we create black holes if you come here, yes? Okay, maybe. I appreciate you guys, yes?
When you do about vertical and horizontal asymptotes, do you always have to make those like walls? And are the walls always in the same place, or do they change based on like that?
Well, I mean, it changes based on what I get here, right?
This aspect.
Yes, totally.
With the walls. would be-
Oh, no, those aren't walls, that's the function.
Oh.
Once I put the walls, then it can only be up here or down there in this first region. Here, it could do a lot of things, but it's really gonna be dependent on if there's an x-intercept or not. If there isn't an x-intercept, it has to look almost parabolic. And over there is the same thing as there. It can only be up there or down there. Okay, so maybe. So let's look at this specifically. Maybe right after this, let's do a concrete example. Dear God, Jeff. Maybe the one we got right in front of us. Okay. Focus. Okay. Can somebody, here's what I do to figure out f in -4. I use this. So that would be 3 times -3 times -5 over -1 times -6. Okay. Does anyone see where I got those numbers from? I just took the factored form. It's just easier to do in my head. So this will be, look what I can do. All the negatives cancel, yes? 3 divided by 6, there's a 2, so this will be 15 halves, which is 7.5. Okay. Now, real quick, I don't blame you if you just throw in your calculator, that's fine. You have them, you can use them. I'm okay with them. I just like to remind you guys, we're the humans here. We made all this shit up. Okay. Is everybody with me? I'm just figuring out where the point is. So at -4, it's at 7.5. So look, at -4, it's at 7.5. I'll bet you it'll end up here, but we'll see. What about f of 3? That'll be 3 times 4 times 2 over 6 times 1. You guys see that? 3 plus 3, 3 minus 2, 3 minus 1, 3 plus 1. You guys see that? We're just throwing a 3 in. So let's see. 2 and 3 go into 6, so I end up with 4. Look at that shit. All right, so 2 things. I now know what I want my y-axis scale to be. What was my y-intercept? Careful. That was my horizontal asymptote. What was my y-intercept?
1/2.
1/2. 0, 1/2. So what's my biggest? I need you with me. How do I determine what I want my y-axis scale to be? Well, what's my biggest frickin' y thing? What's the biggest y thing?
This the X second.
No,
It's a problem.
right? What point is this? And what point is this? So my biggest y thing is 7.5. Do you guys see that? The biggest y value in a point I have to graph is 7.5. So what's a good scale? Obviously not going by ones. If you have to kind of add your own tick marks, you haven't picked a good scale. Pick a good scale. So what's a good scale? Even better. 2s, right? Don't go crazy and do 5s. Don't give yourself no room to live in. Make your scale just big enough to fit everybody. So you got more room to breathe. So we're going to make a scale of going by 2. Jeff can almost count by 2s. I'm getting there, guys. And then this could be by 1s because the biggest x value I've got is -4, yes. I guess the most extreme x value, I should say. So now let's plot everything. Let me see. My intercepts were -1 and 1. My asymptotes on the x-axis is -3 and 2. Yep, I have a horizontal asymptote at 3, which I'm not going to freak out that it's not perfectly there. Okay. I have a point at -4, 7.5, and I have a point at 3, 4. Now let's see why this lines up beautifully. Do you remember back here? I need you to see, if there was no x-intercept, Is that the situation we're in? Do we have an x-intercept here? The only x-intercepts we have are here, yes? So is there an x-intercept beyond this? So is there any way for it to go through the x-axis? So I already knew it had to be up here because there's no x-intercepts. But look, that point even makes it soft. Now I know it's like this, yes? It's got to slam up against this wall, and it's got to slam down against that wall. Now what's one point I didn't plot yet? The y-intercept, yes. And why is, look why this is so important. 0, what do we say, 1/2. Let me see if you guys see. What was it doing at each intercept, each x-intercept? What was it doing? It's going through. Do you guys see how this has to look then? I mean, if I start at the y-intercept and I go back, it's got to go through, and then it's got to slam up against that wall. If I go this way, it's got to go through, and then it's got to slam up against that wall. So it's parabolic, which is one of the situations I told you about. But this one's a little different. There were 2 x-intercepts, so it could actually look parabolic because it can go through like that. Stop for a minute. Yes?
I am a little confused how you got 15/2 to equal 7/2. Because, like, so what happened to the 3, to the first 3 over there? Because I can see 3 times 5 is 15.
Totally.
But what about the
3
other
over
3?
6 is 1/2, so that
Okay.
the other 3 cancel.
Okay.
Yeah.
I wanted to make sure.
But just put it all on your calculator. Do 3 times 3
Oh.
times 5, divided by 6, you'll
Okay.
get 7.5.
Okay.
Okay. I'm sorry. I'll show you the way I do it. You never have to do it the way I do it.
Okay.
You got a calculator. You just shove it in there. As long as you tell the calculator what the top is, what the bottom is.
Okay.
Yeah. Okay. And of course, what's it gonna look like? I'm sorry. Go ahead.
It's not negative, it's square, so y should be max.
What? Sorry.
It's not negative, it's square.
Negative x squared.
Equation.
He's talking about the parabola. Why is it flipped down?
Oh! Oh! Is this a parabola? Is this a parabola? No. There's no reason. Yeah. So this, I was very careful the way I said this. This looks like a parabola. This looks parabolic. Is it a parabola? No, it's not a parabola. It doesn't, it's doing what it has to do given that it's from this rational function. I need you to be with this. This is a rational function. This is a polynomial divided by another polynomial. That's weird already. Parts of it might look like shapes we've talked about before. That doesn't mean they're going to follow the same rules because it isn't a parabola. The middle just looks parabolic. That's all. It doesn't have to do anything. In fact, here's something weird for you to consider. Let me see if I could push this. Let me see if you're cool with this. Watch this. You ready? All right. Dear God, I'm going to say this. You don't have to look at this like this at all. For a number between -3 and 2, do you see how the bottom would be negative? If I put 0 in there, the bottom is negative. If I put 1 in there, the bottom is negative, correct? So then it is negative x squared in the middle. Do you see that? Dear God, you do not have to look at it like that. You don't have to know ahead of time it's going to be opening down, whatever. That's just because you had you had a good question. What part of this tells me I should expect that? What I just said, but you never have to do that. Okay, all right. I got one more region left. So far, is this good? Is it looking like a function? Does it pass the vertical line test? Yes, so you should do that because I always get somebody who goes too far or they draw it in multiple places. I'm like, if you would have just taken a second, you would have gone, oh shit, I did something wrong. So over here, it was either here or there. It can't be here because there's no x-intercept. Also, it must be up here because there is a point right there. So it's got to slam up there, and it's got to slam up there. Okay. Now listen, if you didn't expect a function that is made from dividing two polynomials, if you didn't expect it to look weird, You gotta check them expectations, right? Of course it's gonna look weird. I'm dividing a polynomial by another polynomial. This graph is gonna look weird. Do you agree that graph looks weird? The graph looks sad. Look at him. Why did you graph me? Right? Yes.
How are you determining how far means?
Oh, that's a total guess. I know I have to. If you graph this, it might get there faster or get there slower. I don't want to see that shit. I don't want to see perfect.
Okay.
So what I've got is I've represented everything we discovered. I've represented it. This middle parabola could be skinnier. It could take longer to get there. If it does, and you do that, I'll start to be concerned that it came from the graph instead of the other way around. Does that make sense? So I'd rather your graph be imperfect. Let's see, let's try to graph this, see what it looks like in the calculator. 3x squared minus 3 divided by x squared plus x minus 6. Here, let's make the window the same. So x is going to be -5 to 5. I'm going to make my scale exactly the same. -5 to 5, and then -10 to 10, yes. Sorry, I'm not showing you what I'm doing. -5 to 5, -10 to 10, to match exactly the scale we used. That should give it a chance to look more like what we got. What do you guys think? Oh, I left something in there. Oh, he's still in there. Oh, shit. Get out of there. Let me put in here 3. There we go, since that's the horizontal asymptote. What do you guys think? Does that look pretty close? Yeah. And does this, do you see how this is, eventually if I went further, it's going to approach this red line and this is already there? Do you guys see that? Okay, maybe. Screw you, Jeff. You suck. Okay. And if I wanted to, I could try to put the, I'm not even sure I had to tell the calculator to do that, to be honest. Anyway. So, could you guys, please, try to get as far as you can with this? Let me see, did I make this weird? No, maybe I did. No, I didn't, good, okay. I didn't want this to be too weird yet. Just get as far as you can with this. You can have people near you that you can discuss this with. Stay away from graphing it first. Try to graph it and then graph it by hand and then check it in the calculator. What are the vertical asymptotes? Yeah, 0, -4, and 2, yes? What situation are we in for the horizontal asymptote? Bottom degree is bigger, so this asymptote is going to be y equal 0. Good, so the bottom grows really fast, top can't keep up, gets smaller, goes to 0. Never gets there, approaches it. So let's see, I can kind of plot what we know. So the x-intercept is -2. I can use a scale of 1 on my x-axis because all my x stuff is within -5 and 5. So I got an x-intercept at -2. I have a, use purple, let's see if this shows up better. What do you call it? Vertical asymptote at 0. I have a vertical asymptote at -4. And I have a vertical asymptote at 2. Holy shit. I have a horizontal asymptote, y equals 0. Y equals 0 is just another name for the x-axis because every y on the x-axis is 0. Why is it okay that this point is there though? See it's going through the y-axis? I'm sorry, the x-axis, the the horizontal asymptote? Why is it okay that it's going through the horizontal asymptote?
Because it's just touching it.
Huh? Because x here is not. Okay. When does this kick in? When x gets really big. Is x really big yet? Nope. So it's allowed to go through. Yeah. Okay. So this, everybody hopefully could get to at least this point here. Then the question becomes, what points do I need? Right? This middle, in fact, did I say at most 2 points?
Yeah.
We might need more. I might have changed the function at some point. Let me see if you guys, so over here, there's no x-intercepts, correct? So it could either be here or there, yes? So I have to plug in, what makes sense to plug in to figure out where it is? -5. So let me change this restriction. I think I changed my function at some point. So I want to know what f of -5 is so I can see where it is here. So here's one region. Here's another region here. I know it's going to bounce here, yes? And I know it's got to go up against these walls. So it could either be here or there. So how many points do I need to plug in this region? I just need 1 point. If f of 1 is here, I know it looks like this, because it's got to bounce. If f of 1 is there, I know it's going to look like this, because it's got to bounce. So we need to know what f of 1 is. In here, let me see if you guys are really quick. Does everybody see the regions? Does everybody see that I have 4 regions? There's one here, there's one here, there's one in here, and there's one over there. 4 regions, yes? In this region, are there any x-intercepts? So can it look like a cubic? Can it look like a cubic?
No.
Because there's no
X-intercept.
x-intercepts. So it has to look like a little parabolic, doesn't it? I just have to know if it's up here or down there. So what's another one? F of 1. Did I already do f of 1? Oh, I meant this is f of -1, I think, yes. And f of 1. And then over here, the same idea is back here. It's either going to be up here, or it's going to be down there. So I got to figure out what f of, let's say, 3. Okay. So at most 4. At most 4 more points. Okay. So now take a minute and plug those in. Let's see if we all get the same value.
Could you do something similar like this on the test?
Do it again.
Do we have to do something similar like this on the test with like test different points and stuff?
Yes. Cool. And there I'll be more careful about. I think I changed the problem and I forgot to change the 2. But yeah, I'll be more careful about telling you how many points to use. If I don't say at most something, people start plotting 20 points. And I'm like, no, that's not the idea. Let's see, 35th, which is about, what would that be? 102 something? 102 something? So it's like 103, okay, so it's almost 0, yeah. But it's negative is important, huh? Sorry?
Oh, no. Never mind.
And then -1 would be 1 over -1 times 3 times -3. So that's 1/9, which is about 0.1. It's positive, that's the important part. F of 1 is 9 over 1 times 5 times -1. So that's 9/5, which is 1.8. Oops, -9/5. And again, it's pretty with where these are coming from. F of 1 would be 1 plus 2, 3. It would be 9 on the top. 1 times 5 times -1. So that's -9/5. Yes.
Is it not positive 0.03? because I thought -5. So 2 squared is 4 plus -5 is -1, and I got still
Whoa,
caught.
whoa. What 2 squared? What? -5. So -5 plus 2 is -3 squared is 9.
Oh, okay.
And then
Okay. I
yeah,
think
yeah.
what I did wrong.
negative, yeah. Okay. And then 3 plus 2 squared is 25 over 3 times 7 times 1. 25 over 21 is just a little more than 1. It's like 1.09
09 if you're rounding up.
Okay. So it's about 1.1. Okay.
Sorry, 0.08. It's 6 something. So there's not. Well, I guess you could round up to that too.
Yeah. Okay. I'm doing this by hand, so even 1 decimal place is almost silly, but I'll go that far. Okay, so so now I know what to make my y-axis scale, and here's something new for us. Do you guys see how my outputs do not get very big at all? And here's something you guys don't get to see very often. I could make my scale go by less than 1. Isn't the biggest output, like the most extreme output, is almost -2? So I'm gonna go by, let's not push this too hard. Let's just go by, I could go by a half, 1, yeah, let's go by a half. So it'd be 0.5, 1, 1.5, 2, 2.5. So you can be nice to yourself. Your scale, as long as it's consistent, it could be anything you want it to be. Except 0. So now if I plot this, -5 is -0.03. So I know this is down here. So it almost didn't matter what the output was, it's the fact that it's negative. So I know that this is down here.
Wouldn't it be closer to 0.05?
0.03,
Right.
not 0.3. 0.3 would be close to
Oh,
0.5.
okay,
Yeah.
gotcha.
And 0.1, f of -1 is 0.1, that's roughly right there. So now I know, since this bounces here, I know it's got to do like this. There, the parabolic there. F of 1 is -1.8. So now I know, now this is a little weird. I'm going to have to assume that that's like a vertex, sort of, and it could do like this. Because it's right in the middle. And then f of 3 was 1.1, so then I know this is doing like this. Tripedelic. And again,
Why are we avoiding this? Oh wait, yeah, 0 was thing. Forgot about it. Never mind.
no worries. Yeah, I should kind of extend that. Yeah. Okay. This is beyond exciting, so I appreciate everybody being calm. So let's see real quick. X squared plus 4x plus 4. Now that we're done graphing, we can check it. X cubed plus 2x squared minus 8x. And let's set my window. Let's see. Window x is -5 to 5. Y is -2.5 to 2.5.
This sounds good with scales.
There we go. Yeah? You guys with me? Yes? Yes? Did I get it exactly right? Did I get it exactly right?
Yes.
No, I did not. No, I didn't. Look at my parabola. Isn't it more pointy than it's supposed to be?
Looks perfect to me.
But my God, if your parabola looks like that, there's no way in freaking hell you should know that. Does that make sense? This is what I'm trying to tell you. Don't just copy from your calculator. Look at this guy. This guy is supposed to be kind of like leaning back. Do you see that? Do you guys agree with me? Isn't that guy kind of like, what are you doing? I don't want to see that shit because there's no way we would know it. I just want you to graph based on what you know, and then just check to make sure everything looks to be in the right place. If something's drastically wrong, go see if you can find it. If you can't find where you made a mistake, don't change shit. Because you will lose more points if your graph is right and your work is not. Not nobody, let me be careful. Some people don't believe me when I say that. Because it's weird to hear a math teacher say, I'd rather your answer be wrong. But it's because I am testing you on, can you take this and make it graphical? And if what you're taking is wrong, I want that to show up in the graph. You have checked the box of, oh, you know how to graph what you just got. That's checked. You'll lose points for the one mistake, not for another mistake. Maybe. Maybe my calculator's bored of me. It's okay. All right. This is going to take some practice. Yes, sir.
Will it always be like parabolic in the middle sections?
No. It could be cubish everywhere.
Okay, that's what
It just totally depends. That's the trap of like, I don't care how many examples I do, I'm never going to show you everything that could happen. There's no way. So literally every time you do it, you should expect some parabolic behavior in some of them. You should expect some like cubish behavior in some of them. But does any one have to have any of that? No. Does that make sense? I could have one that looks like little parabolas everywhere. I could have one that looks like little cubish things everywhere. It just depends on what's in the function.
It's just weird because when you have like, you know, the arrow signifying that it approaches that vertical asymptote, and you have like a cubic, it looks like it's kind of, it should approach.
Yeah, so like if that would have been go through, this would have looked cubish. Yes? Okay. All right, so here's the last idea. One I've been saving. Oh, don't forget. Okay. Did I turn that camera back on? Yeah. Good. Is it recording? Yeah, okay. What was I about to do? Oh yeah, that's right. What if I have this? Oh, that's not too bad. There. Now I'll start with this example. What's going on here? If I'm looking at like horizontal asymptote, that's what I want to focus on.
The top is bigger than
The top degree is bigger, which means the top grows faster. If the top is growing faster, what's the whole thing doing? Like this. Does everyone agree the bottom is growing? As x gets bigger, the bottom gets bigger, yes? The problem is, it's something like this. It's something like 1 over 1, 10 over 2, 100 over 3, 1,000 over 4. That's not what it's doing, but that kind of captures the idea. The top is growing faster than the bottom. So what is happening to the sequence of numbers that I get? 1, 5, 33 and a third, 250. What are those numbers doing? They're getting bigger. Do you agree that they will continue to get bigger forever? So therefore, is there a limit? Is there a place this is approaching? No, it just goes up. Now here's the neat thing, and it's okay if you don't agree with me. You're all probably like wondering how I define neat. Could you take a moment and synthetically divide this? Oh wait. Go ahead and synthetically divide it. So we're going to rewrite this improper fraction as a mixed number, basically. Yeah, that's right. Good. I'm glad I did that. Okay. What do you guys get? Good. -1 over x minus 1, right? Now listen. How did I investigate horizontal asymptotes? What did I allow to happen? Yeah. No. To investigate horizontal asymptotes, I let x get big. I let x go to infinity, right? In fact, did I used this notation before, right?
Yeah.
Yeah. So I'm taking the limit as x goes to infinity to this. What happens to this guy when x gets really big? It goes to 0, yes? So listen, when x gets really big, this graph of this function is going to look like this parabola. When x gets really big, this piece of it goes to 0, it's going to look like this parabola. So if you long divide, or in this case synthetically divide, this is your, what we call a slant or oblique asymptote. It's not a horizontal asymptote because it's not horizontal. It's at an angle, yes? In fact, this one is kind of curvy. So watch, if I graph this thing, let's see if I can do this. Woohoo! Jeff, this is probably going to take longer than just putting it in fresh. Oh, it totally is. Okay. That was such a shortcut, Jeff. Okay. I think I got it in there, right? I'm going to zoom 6 this bad boy. Let's see what happens. Oh, okay, perfect. Look at that. Now watch. If I also put in here, let me zoom out a little bit. I don't want to zoom out too much. Let me see. Let's see what this does. There we go. Now, if you ignore this, what's that look like? Parabola. In fact, if I put the equation here, you see that red line? Isn't that capturing the behavior as it gets really big? What's it doing in the middle? Whatever the shit it wants to. What's it doing at the ends? What it has to do. It has to follow this. So it goes to infinity, but it goes to infinity in a very specific way. As x gets big, it has to approach this. When x is small, look what the shit it does. It gets as far away from that as it can. It goes to infinity. Because it can do whatever it wants to when x is small. When x is big, it's got to approach that red line. So, slant asymptotes. I don't normally call them oblique. I just can't remember what the textbook called them. Slant asymptotes, you long divide or synthetically divide to find them. They're going to go to infinity. They're just going to go to infinity in a very prescribed way.
That would be the case every time we have
A top degree higher than the bottom. Yeah. If the top degree is higher than the bottom, you got to get one of these funky ass. Now, most of ours are going to be linear. I just wanted to show you a parabolic one because those are kind of nifty visually. Most of the ones we're going to do are going to have linear, and that's why slant asymptote makes even more sense because it's slanted. And my graph can do weird shit, and then it's got to approach that line on either side. It's got to approach that line. Yeah. Okay. Thank you.
What if it's like the top degree is bigger than the bottom, but the bottom isn't just a degree of 1? How would you?
Yeah. Then you long divide.
You won't divide.
You long divide.
Oh, long.
Yeah,
Oh,
we
long
can
divide.
always divide. It's just I'd rather synthetically divide if the bottom is linear.
Right.
But
Okay.
if I would have put a squared here, maybe +1, then you would have had to long divide.
Okay.
Yeah. All right. I think that I'll let you guys out a little early. Next time, tomorrow, we have the quiz, and then we're going to get into chapter 6. And I assume with 6, we should be able to catch up a little bit because I think I told you guys this, a lot of the sections kind of overlap. So we should be able to introduce the idea and get a little far, a little quick, we'll see.
Bum bum. All right.